So my first presentation is about two French mathematicians and scientists, Descartes and Pascal, and their contributions are towards the society we live in today. So first of all, they were both philosophers, and René Descartes is really famous for his line, "I think, therefore I am," which is, people were contemplating, like, is God in charge of us? Are we in charge of us? Do we even exist? That kind of stuff. But now they both came up with a lot of different theories that we use today and we still find useful as of now. Especially stuff like Pascal and Descartes. So René Descartes basically came up with the Cartesian system, or the Cartesian plane, which we graph everything on, basically. And even exponents and the notation for them. He didn't think of exponents. And then Pascal, binomial expansion is what he's really famous for in terms of math, but also pressure. He has a unit named after him, obviously, Pascal's. So curves and functions, Descartes, he was really revolutionary in thinking that a variable could be more than just x squared or cubed, in which people thought, oh, well, x squared is area, cubed is volume. And then also his superscript was very influential, and so people could think of exponents in a specific way and not have to use everyone's system everywhere. Also, calculus. Descartes was thinking a lot of tangents and that kind of stuff, and really when he laid the foundation for Newton and Leibniz's calculus. So binomial theorem, binomial expansion is Pascal's triangle, and as you can see here is an example of a line, right? And he was really influential as well. Also, what a lot of people like looking at is in Pascal's triangle, there's a lot of different patterns that arise, and even like something as simple as odd and even numbers really pop up. Moving on to science, mostly physics, Pascal with his theories on pressure and vacuums, and Descartes with his theories in conservation of momentum. So Pascal, as most of us know, talked a lot about pressure, right? And he really came up with that with talking about vacuums, because people didn't think they existed, right? And this is one of his first experiments with a little liquid and just a little hole, right? And as he took his finger away, it went up instead of down, proving that vacuums do exist. Also, preceding Newton, Descartes' first three laws of motions are basically Newton's three laws of motion. I'm not going to read them to you because they're kind of long. But he basically thought of and laid the foundation for Newton's laws of motion and used his applications of math to calculate different physical properties. So this is his way of thinking. Descartes was mostly a philosopher, and so he didn't really do many experiments. It was all logic that he used, and that's why he's more known as a mathematician. On the other hand, Pascal always preferred to actually plan experiments and make his own experiments to prove his theories. And so, since they lived in the same time period, they both talked, and they actually had a few debates and a few quarrels between them. They didn't like each other. So, wrapping it up, Descartes was more of a philosopher and a mathematician, so he used logic to plot out his Cartesian plane and lay the foundation for all that good stuff. So, thank you, everybody. cool. So my topic was about fuel cells, and as we've learned the past couple weeks, they're very useful. And I'm going to cover basically what they are and what we use them for. So the ignorant, uneducated person would probably think of fuel cells more as like sci-fi technology, right? Things that don't really exist, Transformers or Iron Man or other crazy Hollywood movies. But they're actually really useful, right? We use them, especially in Japan as of now, in homes to power and heat the homes, as well as in cars and generators, electric generators. Just over the horizon, some future cars that are coming out. Fuel cell cars haven't really hit the market that much, but most big manufacturers of cars are planning to release cars. Their applications today is, again, in the house. Many factories actually use fuel cells to power their factories, as well as military applications. Instead of carrying a big battery pack, they can just carry a small fuel cell. The first fuel cell was thought up of in 1801, and the first actual fuel cell created was in 1839. And the first person to think it up was Humphrey Davy. He was a scientist as well as a philosopher. And William Grove made the first fuel cell. Their first applications in the real world were probably cell phones and fuel cell cars, which is how they really became popular, and that was more in the 20th century. But in the future, we could probably use fuel cells in terms of ion propulsion, right? So this is a little model of how it works, but fuel cells can be really useful in satellites, as Ruta said. But also they can, they're really useful in terms of ecological safety, right? So instead of destroying our atmosphere, we can save it using fuel cells because here they only produce water usually, right? And this is a basic hydrogen fuel cell which produces water and excess hydrogen which just goes back into the top, right? And we learn this, how they work basically, and they're just comprised of a bunch of different layers squished together, and electrons go around while protons go through the membrane, and electrons are the electricity, obviously. So there are a bunch of different kinds of fuel cells. Hydrogen is probably the main kind, but there's also biogas and natural gas. And they can be used in a lot of different settings. There is a natural gas kind of fuel cell, which is methane instead of pure hydrogen. And instead of having protons go through the middle, it has hydrogen gas going through the membrane, which is kind of different. Also, there's molten carbonate fuel cells, which have carbon trioxide going through the center, and they also use carbon dioxide in the process, which is better for the atmosphere. But also there are alkaline fuel cells, which have hydroxide going through the middle instead of just protons. And in this case, it's kind of like a reverse process, right? Instead of going one direction, it's the other. But there are also solid oxide fuel cells, which actual oxygen goes through instead of hydrogen. It's also the reverse process. So the two main types of fuel cells, there are high temperature fuel cells and low temperature fuel cells. The high temperature fuel cells are more useful in a stationary setting where you can use the heat energy it generates also as heating. And really, the low temperature fuel cells are what we use in more in like cars and planes and small stuff that we can actually get near and use. So thank you.